Hi, in this video we are going to talk about Model Context Protocol. We are going to talk about what this protocol is and how we can use it with Cursor AI. So this is where it all started. Anthropic from the cloud announced a new protocol called Model Context Protocol. It is an open source protocol which is connecting AI assistants to the systems where data lives. We are going to deep dive into it in this video. We are going to see how AI assistants get data from the data sources. This blog post actually talks about how LLMs are getting the old data that is actually quite old and how with this protocol we can get the fresh data. This is the blog post that it all began. So I suggest you to read it. I will share the URL in the link. So Model Context Protocol has its own documentation. I will share the link in the description as well for this. So an MCP is actually an open protocol that LLMs can get integrated. So MCP helps you build agents and complex workflows on top of LLMs. And with that LLMs, at its core, MCP follows a client-server architecture where we have a host application and that host can connect to multiple applications. For example, in this image, we have a Cursor AI, our IDE, and our IDE can connect to a lot of MCP server, like for example, this is a Jira server, for example, and we can say that connect to my Jira MCP and get task issue 1 and fix that, for example. Then our Cursor AI will call a tool function. It will actually connect to the Jira server, and the Jira server will get the data from the Jira or DB and return it to our LLM. This is at its core what MCP is. So MCP has three features: resources, prompts, and tools. And Cursor supports the tools, which we are going to talk about in this video. Resources are database records, log records, or some API data, something like that. But actually we can get those data with tools as well. Prompts are actually predefined prompts, like maybe we can change them. They can be dynamic as well. Tools are the powerhouse of the MCP actually. With the tools, we can reach the MCP servers and we can get data and we can actually manipulate data. We can make external API calls. We can get DB queries. We can run DB queries. So we can do calculations and system operations, etc., etc. So which kind of MCPs we have? In the last video, we have talked about Cursor directory. If you didn't watch it, you can watch it. And this is the Cursor directory. It belongs to Cursor and it is open source, and they have an MCPs section. In here, as you can see, there are a lot of MCPs. For example, we are going to use GitHub. With the GitHub MCP, you can get issues, you can get repos, you can make commits, or you can create PRs with your LLM, or you can get data from the Postgre with your database, for example. And in this video, we are gonna do a simple example with our MCPs. We will create an MCP in our local and we will use it. So in our example, we have a JSON data in our repository, in our GitHub repository, and it has a JSON file called shimsham dance routine. It is a dance routine, but it isn't actually finished. So we have an issue. The issue says complete the routine. I will show you in a second. So we will use the GitHub MCP in our Cursor LLM and say complete the issue 1, get the issue 1 and fix it, then get the data from the dance MCP and then make the issue, complete the routine, commit it, and then create a PR. We will do it with the LLM. So we will get the issue with GitHub MCP. Then we will create a local MCP server, file server actually. It will return a full dance routine file. It is a JSON file. It will return it. Then we will complete our dance routine. Then we will commit and open a pull request. So this is our repo. As you can see, we have a shimsham routine. It is a solo jazz, actually originally tap dance routine. And it isn't finished. We have half of it. As you can see, we have steps like shimsham step, crossover, take any, half break, full break, and push and cross. And for the GitHub, we will use symmetry. So symmetry is where you can find MCP servers as well, like the Cursor directory. I will share it in the description as well. There are a lot of MCPs in here. And in the GitHub section, as you can see, it has a Cursor integration. So you can find an MCP server, like in this video, I'm going to use GitHub. You can get to the Cursor tab. And as you can see, it is not actually first page. Yes. In the Cursor tab, as you can see, it asks for GitHub personal access token. When you give your token, you can generate a command like this, and you can copy this command, and then you can come to your Cursor AI. There is an MCP section in here. You can say add new MCP server and command to run with your server name like GitHub, and when you edit like I did before, we have a GitHub MCP. With this GitHub MCP, as you can see, there is a tools section in here, which means what we can do with this MCP, like create or update file, list issues, list commits, create a branch, search issues, get issue. We will get issue, for example. There is a create pull request, so we will use this. So let me show my issue as well. So in here, we have an issue section, and I have an issue, and the issue says finish shimsham routine JSON file. Right now, it is incomplete. Okay, so we will do this issue. For example, maybe you are using GitHub issues, maybe you are using Jira from Atlassian or Trello. It doesn't matter actually. The core idea is you are getting data from somewhere, maybe a backlog management tool. Maybe you have a documentation, an in-house documentation in your company. You can get that data that you need with your MCP. Then you can complete and create a pull request, all with prompts. Okay, here I am in the cursor AI. So I have two cursor in here. I have MCP console, which is our actually repository, as you can see. And in cursor settings, we have a dense routines MCP. This is actually a local MCP that I have created. And we have two functions in here. We have a get routine and we have a list routines. So we will get our full routine in here with this MCP. Then we will use that data and finish our routine. So I will open that file, and this is the MCP file server. MCP file server, actually, I got that repository from here. Let me show you. So in the GitHub section, actually model context protocol share some servers, like some example integrations, and they have GitHub, they have Postgres, they have Redis, and they have file system. We will use file system in our example. But they have a lot of integrations in their repository, so I suggest you to check them out. Let me show you the servers. As you can see, the third-party servers, they have a lot of integrations. So this is TypeScript file. They have SDKs for Python and Java as well, and Kotlin. But in this exception, we are going to use TypeScript. So in the index.txt file, there are two critical functions, and they are here. There are two set request handler functions. One is for listing the tools. It is returning the tools. As you can see, we have a get routine, retrieving a specific dance routine, and we have a list routines. So our routines are actually under this folder. We have a shimsham full routine. This is an old file actually. Let me delete it. Okay, so we have a one routine actually in here, and this is shimsham full routine. But if we had one more routine as well, it will be under the routines folder. So it will return two routines in this function. And the other set request handler function is here, and it is the calling function. Actually, it is running the tool for get routine or list routines. Get routine is getting the routine, which we will use, like get shimsham full routine, something like that. And the other one is list routines. And list routine is actually getting all the routines under the routines folder. That is basically what this MCP server is doing. It is actually returning this data. This server is using the transport for I/O. Let me show you STD I/O server transport. MCP is using STD I/O. We can use STD I/O for local development, and we can use production. We can use SSE, server send events, for the production. I will show you the documentation for it later in this video. So we are using the STD/IO server transport, and when we build this package, we can get a reference with here. As you can see, we are using a command and say node, this is my distributed index.js, which is this file. This is the actually built file, and I am giving a reference to my routines folder to access those files. So this means I'm referencing my MCP. So we have two MCPs. One is in a server, GitHub, and one is in my local. Okay, let's say do issue one GitHub task. You can use GitHub MCP and dense routines MCP. Okay, maybe I can give the URL, but we don't have to. Okay, it is getting the routine details. It is getting the issue. Okay, yes. Okay, it is updating the file with the complete routine. It is updating the file. It has to. It says I did it, and let me close the issue since we have completed the task. Does it? Did really? It has pushed the main. Okay, and let's say first create a pull request. Okay, it is creating a pull request. It is creating a branch. It is creating a pull request. Use branch feature YT for routine for PR. Okay, it is creating branch that I have given, creating or updating file, creating the branch with the MCP tools. If you remember, creating branch like from here, it is actually committing it and creating a pull request. Created. Where is it? Create pull request. Okay, it says I did all the steps, and let's see in the pull request section. Okay, we have a pull request and we have 0 changes because it is from the a new branch to the main, but open PR to master, not main, because they are the same branch. We don't have difference. Okay, let's see. We should have a new one. Okay, we have new file, and we have a shimsham JSON routine, and we have shimsham because I didn't actually specify finish the routine from here, but it has actually created a new file as well. It shouldn't do it. So this actually shows us how we should be careful about it. We need to specify the prompts in detail. So for example, just do the steps that I said and don't do anything else, things like that, because it did the issue that I wanted, but it actually created a new file that I haven't asked. So we need to be careful about it. But it did the issue. It got the issue. It did the issue and connected the MCP server that we have wanted it, and it created a PR. But as you can see, actually, it is great. It is actually showing us the dangerous side of this MCPs, that how it can lead to some dangerous stuff like incidents. So I can ask to it that delete the routines folder and things like that, but I don't want to waste time because you got the idea. The idea was to get the issue, then get the full routine from our server and commit an open PR like we did. And if you remember it, I think it asked I can complete the issue as well. So we can complete it as well if when we merge it. So I want to talk about inspector tool. It belongs to the model context protocol. Inspector is a tool, a UI for testing your MCPs. And how you can use it? You can just run npx model context protocol inspector. For us, it is not built, it is dist. So let me come to the cursor and open my file server and say npx model context protocol inspector, not dist index.js. Yes. Open it, starting MCP server. IUI is here. I think I've opened before. Yes. So my transport type is stdio. It's not SSE. It is for local testing. My command is node. My argument is not distributed this index.js because I need to give the path for my routines folder as well. So I will copy it, paste it here. Routine. I am giving my routines path. I'm connecting. Okay, it has connected. As you can see, it is showing us the tools. It has the tools. It is listing the tools. Okay, let me list the tools. Okay, I have get routines and list routines. Let me show the list routines. Okay, it has some optional properties around tool. I have a shimsham routine, right? Okay, let's get the routine shimsham, and we have the shimsham routine. So this is a tool that you can test your tools, and it has a lot of features for prompts and resources as well, but we have tools in this example. So this is how you can use to test your MCP files, MCP servers. So I want to talk about some extra libraries that you can research about. So there is Super Gateway. It is actually a gateway to convert your HTTP/IO to SSE. So we have awesome MCP servers. It is an alternative to cursor directory MCPs. There are a lot of MCP servers in here. So probably if you need a tool for MCP, you can just find it in here, or you can find it in Glama AI. There are a lot of MCP servers in here as well. So I want to talk about the best practices section. Yes. So there is a best practices section in here. This is the model context protocol documentation, and says keep security in mind, validate inputs and appropriately. I think it is important because there could be some potential security issues in the MCPs. And we have built-in transport types. So model context protocols have two types of protocols. It is stdio and it is SSEs, server sent events. For the local things or CLIs, you can use stdios. As you can see, building command line tools, implementing local integrations as well. We can use stdio like we did, or you can use SSEs. You can use for restricted networks. For example, if you are creating an MCP that you want to use in your company, if it is a private network, you can use SSE, or you can create some custom transports for your needs. MCP Go. So Model Context Protocol doesn't have a Go SDK officially. So this is an unofficial Go repository. If you want to write MCPs in Golang, you can check out this library. It is an active library, as you can see. So this is what Model Context Protocol is. You can, with the MCPs, you can use a lot of tools and integrate to your Cursor AI or your LLM like Cloud Desktop as well. I think it has a lot of potential and you absolutely need to check it out. That's it for this video. See you in the next video. May the force be with you.